In this video we will see area moment of inertia. It is defined by how much the resistance a particular shape has to bending. Means if the load is bending, then how much the area will resist and how much resistance is there due to the shape. It's a parameter which we can measure and we can calculate how much the resistance will be there. The more will be the inertia, more will be the resistance, and that is because of the geometry, means the area of that particular shape. Now as we have discussed, more will be the moment of inertia, more will be the resistance to bending. So here if we see, let's say there is particular area which is very small, and if we are trying to bend it with respect to x-axis, means we are trying to rotate it with respect to x-axis. So if it is present at a distance dy, this is a distance at a dy from the x-axis, then to rotate along the x-axis in this particular manner, we have to calculate Ixx as area into dy square, means this distance with the x-axis. Similarly, if we want to calculate inertia with respect to y-axis, we have to calculate like area into the distance with the x-axis square. So here and here in distance there will be square, and this will be the simple area of the object. Now to calculate inertia with respect to the perpendicular axis with y and x, means the z-axis. So z-axis we have to calculate the distance with the z-axis. So distance will be Izz will be a r square. R is a distance from the z-axis, and that will be equal to dx square plus dy square. You see r, this same distance is here, so by Pythagoras we can calculate r. So that will be equal to a into dx square plus dy square. Now if we can see here that a dx square will be Ixx and a dy square will be Iy, inertia and y axis. So here Izz will be equal to Ixx plus Iyy. So the perpendicular axis inertia will be sum of the other two axes. So this is called as perpendicular axis theorem. So and Izz is also known as polar moment of inertia, and it is I naught, or we can also denote it by J. So J is for polar moment of inertia. So this is perpendicular axis theorem, and so we can calculate inertia with three different axes here. Now we will look at some basic examples. First is this rectangular. You see Ixx is passing through centroid of this rectangle. Iyy is also passing, but it is in vertical direction, and bb is a base axis of this rectangular. So if we want to calculate Ixx, inertia with respect to Ixx, then it is bh cube by 12, where b is the breadth of the we can say it's a width of this rectangular, and height h. So bh cube by 12 with respect to x-axis. Similarly, if we reverse it in Iyy direction, the breadth will be height and height will be breadth, so it will be hb cube by 12. Now if we want to calculate with respect to bb axis, that if we rotate it, how much there will be the resistance in bending. So here Ibb will be Ixx, because we are shifting x-axis to bb axis. So here Ixx plus area of this rectangle into the distance between these two axes, area into h by 2 whole square. So this is called as parallel axis theorem, where we can shift axis to any distance and we can find inertia. Just we have to know the reference axis, like Ixx inertia we have to already known. So this inertia we can place here, and we can calculate the inertia with respect to base axis. Similarly here, if there is a triangle, this is a center of gravity here, a centroid of the triangle, and here this is the distance h by 3 from the base, and total height is h, width is b. So now Ixx inertia will be bh cube by 36, and if you want to calculate with respect to base axis, then bh cube by 12, and here bh cube by 12 is the total inertia we got by using parallel axis theorem. Like here Ixx plus area of the triangle into the distance between these two axes, which is h by 3. So inertia with respect to x-axis plus area into the distance between these two axes. So this is how we can calculate IB, which will be if we solve this by putting Ixx here, Ixx and Ig are same. So here IB will be BH cube by 12. Now for other shapes, if you see this is a circle, and for circle any axis will be same. So two perpendicular axes I am saying Ixx and Iyy, these both two axes we can rotate it any direction, but z axis will be perpendicular to the plane, so it will be pointing outward to the plane like this. So here Ixx and Iyy will be same because it is passing through diameter. Similarly any diameter will have same moment of inertia. Here it will be equal to pi d raised to 4 by 64, and d is the diameter of the circle. Izz we know from perpendicular axis theorem that it will be summation of both these, so it will be pi d raised to 4 by 32. If we look at this shape, which is a thin ring, this is a circular ring, then it will be pi d cube t by 8. D is the mean diameter of the ring and t is the thickness of the ring, and Ixx will be twice that of Ixx. ZZ will be twice of the Ixx, which will be pi d cube t by 4. So x-axis we can rotate in any direction, it will be same only. So pi d cube t by 8 will be the inertia in any of the diametral line, and z-axis is coming out of the paper. So this is how we can calculate inertia of this circular ring. Now this is not that important, but for trapezium we have to just know about it, how it is there. So if centroid is having x distance with the base, this is the shorter length A, this is the bigger length B, and height is h. So x will be 2a plus b upon a plus b into h divided by 3. That will be the center of gravity, centroid distance from the base, and inertia will be this formula. This is not that important, but if you want to calculate, we can calculate like this. So this particular axis we are having this inertia. This is important. We having a rectangular, and there is a rectangular hole inside it. So this is the only area we are interested to find the center of gravity. Moment of inertia. So Ixx is passing through the center of both this rectangle, and there will be centroid point here. Now B1 H1 is the base and height of the bigger rectangular, and B2 H2 is the base of the smaller rectangle. So now if you want to calculate for this particular shaded area, then Ixx will be simply summation that for bigger rectangle I1, and for smaller rectangle we have to subtract because it is a hole. So here minus I2. For bigger rectangle it is B1 H1 cube by 12 from this rectangular formula, and minus I2 will be B2 H2 cube divided by 12. So this is how we can formulate for different shape, and we can also have a circular hole, and then we have to subtract circular moment of inertia from the rectangle, or we can have a rectangular hole inside the circle, then we have to do accordingly. So we can have various moment of inertia, and we can find any shape by using perpendicular axis theorem and parallel axis theorem here, and we can also use this simple calculation to find for different kind of shapes, and these are very common direct questions asked in different examinations. So thank you for watching this video. In the next video we will see moment of inertia for mass. We will see mass moment of inertia, and subscribe the channel and share it, and see you in the next video. Thank you.